my final proof for this chapter is going to be a three-dimensional proof. You can see I have a plane here. I have several triangles standing vertically on this plane. Okay, so I'm told that those points there really are on the plane. And angle PQR and PQT are right angles. So I'm going to mark those right angles. PQR is a right angle and PQT is a right angle. And as a result, what I'm going to try to do here is I'm trying to prove that PQS, that's this angle right here, is a right angle. I noticed that PQ appears to be perpendicular to the plane, but I wasn't told it's perpendicular to the plane. So if I can show it's perpendicular to the plane, I know that it's perpendicular to all lines in the plane that pass through its foot, and that would also show me that this PQS from this third triangle is also formed by perpendicular lines, making it a right angle. So I'm going to state what I know. I know that PQ and RQ are perpendicular, and the reason being, if lines intersect to form right angles, then they are perpendicular. And I know the exact same thing about line PQ and QT, so I'm going to also say that PQ is perpendicular to QT, and that's for the same reasons. I'm just going to leave it as part of the same step. You can add another step or not. And what that tells me then, referring back to my mailbox problem from class, if you measure right angles from two different sides, you can show that a line is perpendicular to a plane, and that's what I've done here. So now I can say that PQ is perpendicular not only just to those two lines, but it's perpendicular to plane M, and the reason being, if a line is perpendicular to two lines in a plane, passing through its foot, and if you don't use this book, that's passing through the line that's the intersection point with the plane, which is Q, then it is perpendicular to the plane. And this is very important because now I know if a line is perpendicular to a plane, it's perpendicular to all lines in the plane passing through that foot. So now I know that PQ now has to be perpendicular to all lines passing through its base. I know as a result that PQ is perpendicular to QS, and the reason being, if a line is perpendicular to a plane, then it is perpendicular to all lines in that plane passing through its foot. And of course, at the end, if those lines are perpendicular as well, I'm going to get a right angle there. So I'm going to be able to say that angle PQS is a right angle, and that reason is if lines are perpendicular, then they intersect at a right angle. And that is the final proof.